Hello, I'm Seung-nong, presenter of Defined Program. Defined is a program for learning multi-thread programming, and Defined is a multi-keyword text searching program. This defined programming requires multi-keyword search, use of the pthread library, use of file and directory pointers, and a queue data structure that can be used with multiple threads. For this reason, in order to understand the pthread library, it is necessary to understand the lock mechanism and to control the race condition from occurring. I also need to ensure fast performance by using proper data structure queues. When searching keywords using file function, I can distinguish what is the text file that I want. My tfind program supports multiple keyword searches and makes full use of the pthread library. Also, a queue data structure was created and used according to the pthread. However, my tfind has big and small problems. First, thread control is not perfect. Second, there is no response to the kill signal. Finally, tfind is terminated unstable. Before looking at the actual code, I will explain the flow of the program with a flowchart. After tfind executed the user's command, it checks the command's requirement, then preprocesses the input directory and then in queue. If there is nothing left in the queue, all nodes have been processed properly, summarize everything, and the program terminates. If there are nodes in the queue, they are continuously dequeued to receive and handle information. This flow description is more detailed. In order to dequeue, remove the node from the head and connect the existing node. Therefore, all codes with node movement must be protected with locks to safely dequeue from race conditions. The node that has finished dequeue only has one thread, so I can release the lock. Locks are not included in unnecessary codes as much as possible because other threads can work quickly when the lock is released and transferred quickly. Return directory information as a character pointer through dequeue. When enqueuing, it is better not to use a lock mechanism because race conditions do not occur when creating nodes and inserting information. So use locks only when attaching nodes to the tail of the queue to avoid race conditions. The code on the left is an algorithm that uses a file and directory pointers, removes the symbol link, and finds only text file among files excluding symbolic link files. The code on the right is an algorithm that reads a text file, finds a file with keywords, and prints the sentences. This code creates as many threads as the user wants and executes the algorithms described in the previous PPT. This video clip shows the full code. The code constructs the data structure first, and then implements all the functions for the queue. Next, I implemented a function to be executed by the thread, and a function to summarize the result. In the main code, after pre-processing the directory, it calls a thread to request the results. The following video clip is a live demonstration. I've browsed the open source software class further in my account on the feed server. As a condition, 5 threads were created and an int word of int was searched. As a result, a very large number of sentences were retrieved. But I have a problem with my tfind program. It didn't end perfectly as in video. As expected, there seems to be a deadlock problem. It is recommended to minimize the use of the rocks to avoid deadlock problems, but it is not possible in my case. Therefore, it seems to be a perfect program only when the deadlock problem is solved. Thank you for a semester, professor, and TA. Please help me in the summer and next semester. Thank you for watching my video.